Hello, guys. Hi. Thank you for joining us for this session. I'm Nimra, and this is Ramsey. Quickly, a little bit about us. So for some of you who were with us in our previous session, you might already know this. But for others, we work with the supply chain engineering group, and that's part of the core services engineering. So what we do is we build services and applications that powers the Microsoft supply chain. So all the Microsoft first-party devices like Surface, Xbox, HoloLens, Kinect. So we are the ones who build it, who ship it, who deliver it to you. And we are in this journey where we aspire to make our supply chain world class. And what we are doing is we revisit the solution we have implemented in the past, and with all the new offerings which Azure has these days, right? We want to improve them. And today we're going to talk about one of those solutions which we implemented in the sourcing world. So before getting into the problem, right, sourcing, what is sourcing about? So in the supply chain world, sourcing is, in very simple language, right, sourcing is about figuring out how to source a specific material I need to build a device. So what sourcing really cares about is who's the supplier, what will be the price, what's the lead time, what's the quality of the materials I'm getting from them. And if you think about any finished good, right? Say this laptop over here, the Surface Pro we have, it consists of multiple parts. So it might have a battery, a lid, a screen, a motherboard, and those parts in turn consist of multiple parts. And then again, you can have another level of hierarchy, right? So on and so forth. And this is where the problem lies, because you have this hierarchical structure with the parts, and then each part can have multiple suppliers. You can have different alternate parts for the same material. Then you have different suppliers providing different pricing, different lead times, and there's a lot of quality metrics also which goes around that. And one very important thing which the sourcing world cares about is cost of goods procured, and that's the COGP over here. And this cost of good procured is the roll-up of the cost of all these parts involved. And the problem we're going to talk about is related to this calculation. So like I said, you have alternate parts from many suppliers. They have different lead times, different pricing, different quality measures. These measures also change over time on monthly basis, for example, right? And then the crux of everything, the BOM, the bill of material which we have, it's hierarchical in nature. And what we were doing in the past is we were representing it using a relational store. So when you represent a part in a relational store and now you try to build the BOM, what you're doing is you're basically having a bunch of recursive, self-directed relationships to the same table. And doing any calculation over that kind of a structure is very, very tedious and very expensive. And that's what relational store was struggling with. So the hierarchical structure was one problem, and the way we represented the relationship. Now, of course, one thing which you can do is to speed up the whole calculation, you can scale up. And that's the only thing you have with SQL, for example. You can only scale vertically. But again, you are limited by the resources you have. And the last thing, basically, with the current representation of the BOM we had, for rolling up the cost for around 150 BOMs, it was taking 2 to 3 hours. So now imagine a sourcing manager. He or she enters a price in the system, and by the time all the roll-ups are calculated, and for him to realize that he made a mistake at some point, it takes 3 hours. And that's pretty sad. So this is where we optimized. We made a huge optimization, and it was about two realizations. The first one, of course, how can we better represent this hierarchy? And we knew relational store was not working for us. And the second thing was, how can we, instead of scaling up, which was the only thing we were getting with the relational store, how can we scale out? And that was about moving the compute out of the SQL store and see where else can we do the compute operation. So those two were the key things we worked on to improve the overall calculation. And Ramsey is going to talk about how we did it.
Hi, everyone. Thanks. So just to start with, if anybody's not familiar what graph technology is, if you use Facebook, you're already kind of utilizing this technology. So graph is about relationships. It's about nodes, which are entities that are nouns, actual things in the real world. And then what's called these edges are the connections between these different entities. And what's nice is that you only ever create Ben once. There's only one Ben. You're not, in SQL, you're going to create many Bens, right? And Ben has a relationship with Thomas, and that edge has a story to tell. For us, we have in our BOM structures from our devices, we have a part-to-part relationship, and in between the parts, there's a story to tell. And that was the nice surprise that we got once we started utilizing the graph database. So this is pretty much basically what a graph database is. Okay, so the one thing we quickly realized, and what the business was saying, is that they were being very constrained with the current technology solutions. Again, SQL was both the storage and compute for all the BOM data. So we said, okay, let's utilize the graph database. It's really good at giving us a hierarchical relationship, and that's where all the BOM data went. That's where, you know, there was part-to-part relationship, and then every part had a supplier, and every part and every supplier had an owner, and parts had categories. It was just a very natural type of way to design our entities. And then we said that, okay, we already do this. We have distributed compute type of solutions. We know all about Azure Functions. So we said is that we're going to do a nice separation of concerns. We're going to model all of our data inside the Cosmos DB graph. And then we're going to do all the computation, which is distributed across all these Azure functions. And it worked out perfectly, because you do the storage one time, and then you can, in parallel, do the calculations of all the BOMs. So what we did from this is that we said, okay, now there's a sourcing manager. How did we help the sourcing manager? The sourcing manager now goes and inputs a price, and then runs the calculation, and within under 7 seconds, they've got the new updated roll-up cost and say, oh my God, I made a mistake. Let me go back and fix that. Now they can do that. Before, they had to wait 2 to 3, 4 hours before they found out there was a mistake. On top of that, we're able to run all the BOM calculations in just about 19 to 20 seconds. That's a huge, huge deal. Again, what happens is that every month they freeze the prices, and then they run the roll-up costs so that they can hand that over to finance, and finance can go and report it to Wall Street that, hey, these are the volumes we're going to build based on these costs. So it's a very important thing that we're able to do it in real time. We got additional benefits because we did distributed compute. We're able to do macro type of calculations. We're able to do regressions on the prices that the suppliers were offering. And we caught a lot of interesting things that we weren't able to do before, and I'm going to show that in the demo. But before I go to the demo, so part of the stuff that we're doing in real time is that, like I told you, we're rolling up all the BOMs. We're able to do them in under 20 seconds. We're pushing all that information in real time to Power BI via push data sets. So the user now is able to do updates and then go look at the Power BI and see the changes in real time. On top of that, we're sending all the full details so that we have a historical bunch of snapshots for all of the pricing that we have. Okay, so that's all the real-time stuff. Now, some of the learnings that we had, devise your entities wisely. When you create relationships that you want to model your business, it's a very important conversation. You need to sit and discuss. Before you get into the technology, try to understand your business. How are things related? So for us, right now, we just modeled sourcing, but we want to connect other parts, manufacturing. Right? If there's a bad part during manufacturing, we're seeing a lot of devices failing tests because of that one bad part. Wouldn't it be nice to be able to kind of tie it back to the supplier so that we can go and say, hey, we have data that shows that the part you're giving us is not working out very well. Can you help us there? Or we can go to another supplier if that's the case. So devise your entities wisely. Don't put too many things. You don't want to put little details as entities. So for instance, like I said, a supplier for a part, they have prices over many months. You don't want to put that price for every single month and connect that to the supplier. It doesn't belong there. So, and that's what I call reference data. So pricing over many months, that's reference data. So from the edge, so that between the supplier and the part, you can have a pointer to say, oh yeah, my detailed pricing data is sitting in a SQL database or Azure table. And you want to implement CQRS. If you guys don't know what that is, It's just basically taking snapshots for data that's exactly the same. And what I'm saying there is that I go to a graph database one time for a BOM to get all the part-to-part relationships with the supplier, but then I say, okay, I've done that once, I'm gonna put it in a blob storage so that I don't have to go and keep taxing Cosmos DB. I don't want to pay, right? If the data's the same, I'll just go fetch it from hot storage. So one of the challenges, if anybody's familiar with graph, there's a language called Gremlin, which is not that easy to kind of write and to understand. So what we want to do is we want to abstract our users from all of that. And the one way to do any abstraction is through APIs. There is no clean way right now to kind of abstract Gremlin. There is something the community is working on. It's not there yet. So for now, that is one challenge for us. We're just using RESTful APIs at this point. So at this point, I want to get into the demo. I'm going to just show you the power of what Graph can do. So we can just copy that and put it in the browser. So what we did here is that we created a UX that's going to build the BOM, and it's going to do the calculations, but it's got some extra goodies that we're able to do in real time. We're able to find anomalies. We're able to find, hey, the price is going up in this one particular supplier. Yeah. Sorry, it's coming up. No, just hit go. So now this is calling our Azure functions, which is getting in touch with the Cosmos database, and there you go. So this is the model. We left all the labels out because we've got some secrets. Unfortunately, I can't share them with you because I want my job. So at the top is what's called a program. And now here, this is the finished good right here. Finished good is something like the Surface Go that you have right there, or the Surface laptops, or whatever laptops. That's the top part. And that's made up of bigger parts, right? And then this is what's called a sub-assembly. These orange boxes are sub-assemblies. And these sub-assemblies, they have other parts and other sub-assemblies. So you can see all these numbers. All these numbers were calculated in real time, but there's some other nice things that I want to show you here. So remember, I'm just going to mouse over one thing here. Look at that. This chart was generated in real time just 3 seconds ago. And it was done for every single part supplier. And what it's telling you is that it's saying, hey, there's some data that's missing here. Supply chain manager or sourcing manager, go and fix that. Right? And we're also running regression. So if the price is going up over time, we're going to flag it with a little red icon. And then another thing I want to bring your attention to, maybe you can take the mouse out. You see that little red police blinker? That is a risk. That's saying that for this part, there's only one supplier. You might want to think about having an alternate part, because if this part is bad, all your products are going to be in the water. So you can see here, this is thanks to the graph database and the power of distributed computing, we're able to create really immersive and amazing experiences. And I'll just leave you with this. One of the things that our sourcing managers want is to be able to export to Excel. They just can't get away from Excel. That's fine. We're going to have newer technology and give them exactly what they want, because we can do it. It's so easy. Azure Functions, serverless, has just made all this so simple. Just to let you know, we're not a product group, so we don't give you hello world demos. We actually do this stuff. We've seen all the bumps. We kicked all the tires. If you guys want real solutions, you can come to us and talk to us. So the last thing I'd say, guys, please give us your ratings. Go give us your feedback. We really want to know what you think. You want to reach out and speak with us. We're happy to talk to you. And thank you so much for your attention. Have a great Ignite.